What's going on, everybody? Welcome back to STL Sunday, or 3D Printing Sunday. Purpose of this show is we go through and live 3D model some sort of project that is usually designed around being 3D printable. Normally that includes some sort of scale accessory, and this week kind of no difference. What my plan is for this week is to 3D model up a pallet jack. And if you guys aren't familiar with what a pallet jack is, they're usually like, it's like a walk behind forklift that you can use in warehouses and things like that. So that's the idea of what we're doing this week. We'll be using Fusion 360. Fusion 360 is a program that you can get a personal license for free generally. Things are always changing with that, and I can't explain to you how to get the free license normally, so I can only help you so much there. But that is what we're doing this week. So thanks everybody for checking in. We'll see how this goes. I know I missed last 3D Sunday, but we'll get through that. One other thing, I did not create the, I have been putting a web link in the description here to send you to my website, because Thingiverse sometimes does not, like, I'll upload a thing and it won't actually add the file there that you can visit. I always put them on my website though. So if you go to harleydesigns.com and they'll be like in the blog section, you'll go there and there'll be a new post for this episode where you can go and find the links to the specific items. The Thingiverse just sucks, and I have to send them an email every time one doesn't post with a link, and it's very annoying. But if you always go to my website, harleydesigns.com, go to the blog section, there'll be a post, you can find it there. So that is the plan. Now let's switch over to the Fusion side. So this is the main screen of Fusion. That's the kind of where we live. Now I don't always go through step by step and walk through every portion of how we design this, but I kind of try and talk through it as we go, and hopefully something pops up for you, or gives you a hint, or shows you a way that I do it versus how you may do it. One other thing. This week, I asked Nicole for some bearings, because I normally have been using a lot of 5x11s, but it's hard to use like a 5x11 for certain things because normally we're using M3 screws. But there is a lot of bearings with a 3mm ID, like 3x10x4, 3x8, 3x8x3, 3x7x3. So I'm going to use some of these kind of from now on, and I'll always post or say what bearing size that is, and then I'll always include a 3D printed version of the bearing, because I always like bearings. But I thought this week might be good to use some of these bearings for wheels. Now these are not uncommon RC bearings, but might not be as common in regular 10th scale RCs. Sometimes it's the smaller scale stuff, things like that. But regardless, a little bit of a change there compared to my normal 5x11x4 bearings. Let's draw something though. You can see I put a little bit of a example photo in the bottom there. I'm going to go with like the powered version of these. Now I'm not going to actually power it, of course, but it's something that looks a little bit more interesting compared to just a normal walk behind style. So one other thing is that I'm going to drag this window down. I found this photo here on that site for the example that I used, and it actually has the dimensions of the pallet jack that I was thinking about using. So even better, gives us a little bit of something to look at. We're going to start on the front plane, and I'm going to do that because that photo that I have is, well, there's both a front and a top. Actually, undoing that, I'm going to delete that, and I'm going to start on the top. I usually prefer that, and that's what we're going to do. Now, along with this, we'll also do a pallet as well, because that's quick and easy. So this is 27 inches wide, so that's 2.7 inches wide, 2 in 1/10 scale. And then the overall length, we have to go to the previous photo, and that was 71.2, so 7.12 inches. That's the total length. Now 7.12, what is that? 7.12 times 25.4 is 180 millimeters. So even if we were printing the full length of this, it would fit within most printers, 200 millimeter printers. So the base of this may actually be the full distance. So that's why I wanted to check that to make sure. Now 6.3 is how wide these are. So we need 0.63. So I just drew a rectangle for the base. I'm going to draw another rectangle in here now as well. Kind of dimension some things. So 0.63 inches. I'm typing IN after each of my dimensions because my standard units are millimeters. I prefer to design in millimeters, but for scaling, I'm going to do it the other way. Now that comes out to be almost exactly 16. So I'm just going to actually make it 16 millimeters because I like that much better. And also we're at 68.58. Let's just go 69. Children. 48 inches is the depth of the throat on the forks here. So if that was 4.8 inches, 121. We'll just go 122. Whoops. There we go. Then let's see. Is there anything else? So I'm looking at these kind of top-down images still. My references, just again, to show you guys what I'm looking at. That's the reference image. It's got some basic dimensions, top, bottom, whatnot. That's what I'm using as a reference. So I know I keep looking up and saying dimensions. That's where I'm getting them. We're going to throw some. What's 15 look like? That looks pretty close to the photo. I'll go with that. So at this point, we could, put on the shape of the forks, things like that. But let's keep it simple. So I'm going to hit Q for press pull, and we're going to put some thickness on. I'm just toggling back through photo. It shows that it goes. It's about 3.3 inches thick, so 0.33. It's going to be what, 7 or 8 millimeters? Oops. What is that? That is 8.3 millimeters. 8 millimeters is usually pretty good. I'm going to adjust that to just be 8 millimeters. This kind of give us a good base to work off of. Now, we of course need to put the wheels in the front side, and then there'll be the pivoting wheel in the rear. But I want this to be easily printable. So if I add mounting for the wheels, I need to plan on a couple of things. I need to plan on it to be recessed in from the side, or I need to plan on this printing upside down. Likely the easier way is to have it print upside down, but we'll get there. Now let's throw some shape to the top portion of this. I'm gonna hit P for project, select the whole face, and hit enter. Now, one thing we can do is I'm gonna draw a line. I purposely drew it off center so I could easily select that line and then this one. Using the collinear function, it snaps my line into place easier. And this, now one thing it doesn't tell me, it shows me that the entire handle height is about 50 inches. So I'm going to say that this thing's got to be 30 plus inches tall. Let's say, well, we were 32, say call it 32 minus the 3, so another 30 inches. So 3 inches, 75 millimeters, basically. I'm going to make that a new body, though. I'm going to not have this print all at once for a couple of reasons. One, I want to be able to do some of that multicolor that it shows on there. This is a walk behind, not a rider. So for that question there, I saw pop up. That, and then we need to, I'm gonna do something, this. We're gonna take another cut out of it. We'll call that 25. Oops, that's, we're just gonna cut that down a bit. This is where, and I'm just making up the distances and things like that, obviously. Now you can see in that we've got the handle that's going to go down, and that needs to be tied into a wheel that's going to be at the bottom. And we should have wheels, and they should turn and function, because that seems reasonably overcomplicated for an RC forklift or pallet jack. Now, the wheels in the rear are generally larger, so we're going to need those to be larger. We're going to have to do a 3D printed wheel over top of a hub of some sort or something like that. So let's make a decision on what size we think the wheel should be. I'm going to do a sketch on the front plane, or right plane, whatever that was. And I'm going to kind of estimate. I think the wheels would probably be something about like that in size. What's that look like? What size is that? 16, okay. About 18. I feel like 18 is just a better number. Yeah, we're gonna go with that. And then we're gonna do an inner diameter of 10. So something along those lines. Now, I'm going to position this as well while we're here, just because it's going to give me some points to work off of. We got to make the decision at some point. Anyways, oops, what did I meant 72, not 722. Do that, and then let's do a vertical height. 4 millimeters sounds good. Motor option? No, we are not. We don't have time to worry about all that. So this is going to go there. Trying to think. Want to make sure that everything is going to. I feel like we're going to move that forward a little bit more. No, we're not. That's okay. Right about there is fine. Now I'm going to do cancel. I'm just giving myself a bit of a plan on trying to figure out where everything is going to be. So I'm going to finish that sketch for now. We're going to leave it visible but not used. From there, keep changing my mind back and forth. Let's decide to draw some wheels. Let's do this. Let's make these wheels, these are going to be new bodies. We're going to make each of these wheels, say I put a bearing in the middle of them, because now I'm going to be all about these new bearings that I have. We'll say we use these 3 by 10 by 4s. So let's go 4 mil, 10 mil each. Could go, yeah, we'll go 10 mil each. Negative 10. I'm going to rotate to the bottom. I'm going to move this item. Now, because I drew that right on that center line, but I need to give it room to be able to be mounted to the inner carrier of some sort. And I need that carrier to have enough strength to be able to hold this thing. So I'm going to need at least 5 or 6 millimeters. Let's say I do 6. So let's go 3. I'll do 4. Let's see what 4 looks like. I'm going to do that. And then I'm going to do a mirror also. I'm going to select that. I need to change this to bodies. Select that body and mirror it off of the right face. It's a bit too spread out, but to try and make it strong enough, I think that that's going to be my biggest concern. A little wide, a little strong, but either way, it's going to function still, and their wheels are going to be hidden enough, not like on the style that aren't powered that you don't see them as much. So that's okay. We're gonna be all right. I'm gonna make a cut off of the bottom here, and I'm gonna do that now. Just kind of make it a little bit large so that I can adjust it later. I'm just trying to do it for some visibility. We're gonna do a construction line from the origin to the midpoint, and that is gonna allow us to center it easily. A little 38 wide, 32, and we need a dimension there of 53 is fine. Do that, and we're going to cut that upwards by 25, and then we're going to select that we're only doing objects 1 and 2, or bodies 1 and 2, so it doesn't affect our wheels. So it just created a cavity in the bottom side. So in there, let's do. We're going to create the actual. I'm going to create the hub setup now. So we'll make this like 10, which was our inner diameter. We'll do 2.6, so it'll be threaded. And we're going to extrude that over to the other side. New body. Okay. Hey, Bald and Beautiful. Thank you very much. Hey, Josh, I'm new to 3D printing. Was wondering if it is safe to print in the house or if I should put it in the garage. Mine's always in that. Mine's right next to me, right here. It prints all the time while I'm in here. I'm mainly printing PLA, which is safe. No ABS, fumes, and some people have said, I don't know. For me, I've never had a problem. I don't notice the fumes or anything like that. And, you know, it's also nice to have it temperature stable for prints. Some materials are more finicky than others in that type of situation, but I think a lot of people don't, and it's not much of a concern. So it's not something I'm going to be concerned about anytime soon. There you go. What face did I just select? Selected that. Okay. So did that. I'm going to turn off body 3 for right now so I can see a little better. From here, I'm going to create some geometry that's going to turn into our handle in the end. Things may change. I'm just drawing some things so it lets me complete my thoughts a little better. Well, I'm going to hit project on that to make sure I have that line work. Tangent there. Throw some dimensions. And that will put 2 millimeters is fine. Total thickness 8. That'll work. So And that'll be, I don't know, 35 now. This being a, I'm drawing this as a rectangle, it's not going to work. We obviously need it to have some sort of pivots and things like pivot, but I just need something to think from. Damn it, let me think. That. So that's going to be, well, we'll just do it as a new body for now. And then I'm going to combine it with that other hub piece that we already did. If you hit the A menu, it'll bring up the appearance. And here you can select a number of options of things. And if you want to add some color to parts, it can help in a lot of situations because it can help you differentiate between bodies that you've already created. So you know things are different. Duplicate. I just duplicate and then make the actual colors that I want or don't care. I just want them different enough so that I can tell, you know, which items are which. Obviously, we're very, very square at this point. Nothing very interesting to look at. So, but I need to come up with a functioning wheel setup so that I can feel comfortable about moving forward. Now, one thing that we could do is not bearing support something, which would be the worst thing in the world, right? I'm going to, yeah, that's what, just with, I mean, I could make it off of some much larger bearings, which I'm just not sure that everybody has such a assortment of bearings to waste on 3D printed accessories for no reason. What I'm going to do is I'm just trying to make sure that that initial column that I did, I know it was square, but I want to make sure that it's got enough strength to it. So if I do a 10 millimeter shaft would be all right. So now what's, 10, I could do 10 by 15 by 4s. Those are a common. So we're going to do 15.5 millimeter. That's fine. And then, so that'll work out perfectly. I'm happy with our thought process. Oops. It's going to be a -4 cut. And we're only going to cut body 2, which is all that it's trying to. Okay. Sorry, oh, I need to cut out the center too. So fine with that. Now the actual center of this, we can create a hole that is going to be 11 millimeters, just because that's plenty of clearance. I'm going to cut through to the top. And since everything needs at least 2 bearings, I don't have enough thickness left. I need to adjust. Well, actually, I'm gonna do that. I'm just gonna click. I'm gonna do -4, but see, it took off any lip that I have. I need that lip, so I'm gonna go back and adjust that cut that we did earlier because it was just kind of out of nowhere. Instead of negative 25, we'll go to negative 20. Whoops. If we change our visual style to hidden edges, we can see negative 20 should be plenty. So now I'm going to change our visual style back quickly. So now we'll have that whole, that previous one though. We need to, so now you can put 10 by 15 by 4 bearings on both sides and without any issue. Hooray for us. Now, modifying the shaft, another issue. So we're going to select, make a sketch on that plane. And I'm going to do I'm going to grab the geometry of that circle so it gives me the center. Do a circle. And then I just need to have a lip that's 1 millimeter bigger than the ID of the bearing, so 12 millimeters. And we'll extrude that down by 3. It's going to be a join. Boom. So that'll work there. And now I'll do a cut on the top. That is 10. I'm gonna have to do this in 2 steps just because of the way that I did it, but that's fine. And, well, actually, I'm going to adjust that. We're going to make that 9.5 just to make sure that the bearing slides over without any real issues. So that'll allow the first bearing to go all the way down. You'll slide this to the bottom, then you'll put the top bearing on, and then everything should seat well. Now, the only thing we need to do is make sure that the weight of everything should keep it on, but we'll cap this top in some fashion to make sure that it's held in place. We could do it with a screw even. That actually would be just fine. This only needs to be, we'll make it just proud of the surface so that it's got a little bit of tolerance or wiggle room. So anyway, thanks everybody for joining again. I know I don't read the comments as much during these live streams since I get all focused, but I appreciate everybody for joining in live. Yes, and again, there are a lot of bearings in this, but I will make sure that I also include printed versions of the bearings so that you don't have to use actual bearings. You can just use the printed stuff. Get it done on the cheap. So we'll clean all this stuff up and make it look fancy in a little bit, but I want to get the function out of the way on some of this, and then we'll start prettying things up. Get it ready for the ball. So that's the rear wheels. We need to add the fronts as well. So now I need to add those kind of midway in that fork. Now we can do it a couple ways. We can do a construction plane and move it over, or we can do it even an easier way. And since this doesn't have to be all that exacting, I'm drawing on the right plane. I'm going to hit project to grab the sketch of that wheel. The reason I'm going to do that is I want to draw a line that is horizontal from it and make sure that it has a tangent constraint so that it's in the right spot, because I want to place the front wheel at the same level so this thing sits properly, not doesn't have a rake to it. Now for this, I'm going to use one of these new 3x10x4 bearings that I picked up. So that means that our outside diameter does need to be 10 millimeters. It's set as a construction line. So yeah. Now I want to put a tangent constraint on it to put it in the right spot. We're going to put a 3 millimeter hole through it for now, since that's the exact size. Hey Josh, how will the pallet lock in place? What do you mean by lock in place? Pallets don't really lock in place, they just set in place. Now, technically you won't be able to lift it like a regular pallet. You know, it'll just be on there. Is, you know, it's not gonna fully work, but it's you get what you pay for with this show. It's nothing spectacular. This is mainly to look the part. So while it's sitting around, it doesn't look ridiculous, I guess. So that's just the bearing, and all I wanted it, or the wheel that will also work as a bearing. That's just too small, isn't it? No, the bearings or the wheels on these things are, well, I mean, granted, they're normally smoother, or they're wider and small. They are. So is, that's what it's going to be. I could second guess it, or we could just keep getting stuff done. So I moved that over there. Now I'm going to make a modification to the top. I'm going to turn visual style to hidden edges so I can see where it's at. And then we're going to finish, or I don't know where that sketch is exactly where I needed it. Hey, Jeremiah, thanks. Best $5 I ever spent. Thanks, Jeremiah. So this will be, I think we can get away with like a 6 millimeter opening. These were 16 mil wide, right? So I'm going to do a construction line from the center point. Oh, it doesn't even matter. Center point to center point, and then I'll do a horizontal constraint. And we'll do, that's a 10, so we'll do like a 13 mil opening, just cause. And we just need to place it 16 forward, sure. Why not? Drag that down, cut it through, making sure to only cut body one. Okay. So that's going to get us, it's going to get us that. Now this, you can see, to have this at the same level as the rear, I'm going to need some sort of boss that's below it. So once we get this all split, the best thing to do will be to print this whole thing upside down. That way you don't need any support material. Because if you print it the normal way, then you're going to have support material underneath the whole bottom. And I just, so there we go. Let's do a, whoop, I was already selected on a plane. Delete that sketch. There we go. And hit project to grab that circle. And we're going to do this at 3.5 for a slip through on the front or the back, whatever you want to call it. And then we'll do cut until that plane now we're going to do another circle with an outer. Let's see if we can get away with, really needs to be about 8 millimeters just for strength. Otherwise, when you're trying to put screws through things, they just don't like to, the 3D prints don't like to hold up. Now we'll probably center or like just recess this a little bit to hide it. I think that'll be the way to go for us. The normal head of a button head is like 5.5 millimeters. I think. They are 5.6, so a little bit bigger than I thought. So what we'll do is I'll grab this whole surface and then we can do we'll do 6 millimeters and we're gonna cut that in by 2 like that. And then I'm going to do one more cut on the outside that just goes, and it's only going to be like this section, and I'm going to do that by -1. So just to hide that back a little bit, nothing much. So we'll do that. Now the only thing we need to add is the receiving side of this whole shindig. So I'm going to select that side, hide that wheel for right now. Oh. And then I'll hit project, and I'm just going to grab that, all that geometry that way. And the only thing I'm going to do is I'm going to make the inner hole 2.6 because it'll be threaded. So now we can hit Q, select those two faces, go to there. Make another sketch here. There we go. And since there won't be any screw on this side, you probably won't see it. I'm not as worried about making that kind of countersunk area whole thing. So that, we'll turn the wheel back on. I know the forks are a little thick, but to make out of plastic and all that, we could do, I think we could kind of fake it a little bit with maybe some fillets. Let us. Yeah, I've got. It's all right. I'm not gonna worry about it yet. It's fine. Can't help but think about it, but I'm not gonna worry too much yet. So I'm gonna add the shaping to the front of arc, 3-point arc. So we're going to put some shaping on the front, something like that. Now I'm going to say that this is like a 8. Oh, maybe not an 8, maybe a 6 line. Just going to create some of that. There we go. Arc. These are just using 3-point arcs, drawing some random geometry. that, and then we'll define it. 30, sure. I like that. Equal. Cut through. So gives it just a little bit of something. Now the other thing is that we need to make sure that we do, we need to do all of the foot work, the whole thing to the other side. Thinking about cheating a lot though, so we'll see. So we got all that. We've added the functionality of front wheels. Where was that one? The difference of that lip bothers me. So I'm just going to take it down to that same difference. There we go. That thin little lip was unnecessary. Okay. So we've got that. Now I am looking. We need to add the handle, and then we can start adding a bunch more style to this rear section, making it look kind of that flowy, plasticky look that that thing has. So we know that the bearings are going to sit in here. While I'm here, I might as well just draw. I'm going to draw those bearings so that, for one, I remember I have them or need to upload them. And two, they are for new body. Okay. What is it? X for P is for projection. Weird, right? X is to change lines to construction style, which I also use a lot. X for construction, L for line, C for circle, F for fillet, P for project, Q for press pull, D for dimension. Okay. Now, I know I brought that down, but I'm going to bring that back up. I adjusted that. Because we need the handle part that's going to go over this. And I think what we'll use is, let's use like a keyed style design. So let's do something like this. I'm just going to leave that line kind of hanging. Select it, select that endpoint, do that, and then make sure that's selected. That'll center it properly. Do 5 millimeters wide. Perfect. Project the whole top. We'll hit Q. We'll hit those. And we'll drag that down 7 millimeters. That still leaves us a little bit of flexibility on bearing fit. So that gave us kind of just that rectangle. And the whole reason for that is that I'm going to select these surfaces. We're going to do a P to grab that face for the circle. But I'm going to do just I don't know, select a size. We'll do 16, why not? 16 because that's too big, and I'm going to hit project for the top surface, and then I'm going to offset that by 0.5 millimeter. I could tighten that up maybe a little bit, and go to like 1/4 millimeter, giving me a 1/2 millimeter overall. Yeah, let's do that. Select all of these surfaces. We're going to drag that up by 6. New body, though. How about a 3D printed ripper cage? Absolutely not. 3D printed cages, especially in 10 scale, bad idea. And no on the ripper. But other than that, I just don't like anything like that structural, 10 scale, and functional. I'm just not for it. Now, I did have one printed initially, but I had it done on one of those HP printers, those really expensive fusion jets. And it was still, I mean, those are like really nice printers, and it was still just awful, like awful bad. You just have to do things so much differently. 3D printing is amazing in the right applications. It's overused for because of its simplicity in so many other situations, but you know, it is what it is. But Brian is, and speaking of Brian, I have your I've got your truck already, and it's by the front door. I'm gonna take it into the shop this week and get it out to you. Oh, where did that go? Way over there. I don't know what else time I would have for it, so that's why I'm going to get that ready to go back out to you. Hey, thank you also, Brian Ratcliffe. Yeah. 3D printing is powerful, but it's still layers of plastic stacked. Yes, it's not. It's never going to be, you know, it's not injection molded. You know, it's got different properties. It was made one little layer at a time. And so fancy hot glue guns. So I'm gonna, let's see. This is going to be like the attachment point for the actual, handle. 3.5 there. We need to put a dimension on that. Mike J. Holy smokes, Batman. That was a quick turnaround. Yeah. Projects are projects. I'll get to them when I get to them. And I won't feel bad about it at all. Don't worry. That doesn't affect me. There we go. Got all that selected. And then we're going to do symmetric and total width, say 6 as a join. Hit OK. Thank you, Brian. Any new Vanquish Products kits before I buy my third Ultra? Brian, even if there is or was, I couldn't tell you, and I wouldn't tell on a live stream, especially before we were, before like an official release or anything like that. But you're safe. Don't worry. We can't keep up with the current ones. So, and do that. And then I can just mirror that last function. Mirror. We're going to do features. Select that last one and then the plane. So I'm going to turn my visual style back because that's probably annoying to watch. But you see, this piece will slide over top of that keyed section, and that will allow you to turn the wheels with what will become the handle on this. Now the handles on these keep themselves up, which would be it'd be a good time again for another pen spring, but We'll see. I don't know if I have time. And it seems like you'd need a really small spring. Otherwise, that handle's just going to super fast up. All right. Let's do... Yeah, that'll be fine. And this is also going to be 3.5. We'll do 7.5 for a little bit of clearance. Clearance. We'll go 4 on each side. New body. Oops. We better throw a bit of color at that so we can tell that we're doing it right. Thanks again, Brian. Appreciate it. All right, now let's do a right plane sketch. And the handle on this one, 100 pen springs for $8 on Amazon. Ben's trying to speak my language. So now what I'm looking at here is the upright. Now I'll probably make this handle just go straight rather than having another like bends or anything like that, because otherwise there wouldn't be like a good way to place it flat on the bed. I just want to make sure that it just sits properly flat, and just makes things easier. Sometimes slightly less scale accurate, but a little easier. So this is on the center line, so I'm gonna have to dodge around that part of it, but that's okay. And I need to, well, we'll need to make sure that I'm, actually, we could just, I've already got enough distance off of the center line that I don't need to add more. So we're just gonna leave it pivot on that part. And then I'll work the shroud around it. No, I can't. I just don't like that look. I'm going to hide it a little bit more than that. Wait. So I'm going to go like that. Then we're going to add a line. Something like that. Uh, 135. Nah. 150. Sure. You go this way, say -6. That'll do, pig. That'll do. Oop. Just trying to, why is that over dimensioning? I can adjust the height all I want. This is just trying to piss me off. Do it from the origin if I have to. Sometimes Fusion is dumb. It'll let me do it from that side. Whatever. Gah. So we're going to do this as a symmetric total 8. Yeah, 8's fine. We're going to do it as new body for now. Fine. Then from here, the things we need to do is I need to see, like right now it's interfering with this portion of the pivot. So I need to kind of carve around that, add some room, and then I need to reinforce this so that it's strong enough to go over top of that. Not that big of a deal, but all things we have to do still. Okay, let's add some style. It's still looking kind of boring, so I want to do that. First thing I want to do though is we're going to work on that plane. We're going to put what will be the kind of that console cover. I'm going to hit project for that so I know where that line is, and I'm going to put this, I want this to be over top of that by like a millimeter. So we're going to attach this piece separately, and it's going to help cap everything in. Fillet Central, here we come. Chamfers and fillets. You know what? That's all it takes to make stuff look fancy. Does that look a little boring? Can I interest you in a fillet? That. Say, I think 30 is a great number for that. Now that is going to come out to I'm going to say about there. Obviously I see that it interferes. Nothing we can't carve away. We're going to do that. So, we got that. Do I keep missing any of Brian's questions, or does he just keep sending me unicorn stickers, which are equally funny and I think even better? There we go. Let's do an arc, 3-point arc, and we're just gonna do kind of like a big waterfall cut, something like that. 50 is great. Cut through. Now it's not tangent at the top, but we're just gonna throw a little fillet to get it all blended. 3 there. All right, now some fillet time. Let's see. Got that. Now, I still want to we're going to put a small fillet around the bottom edge just because I think like a 2 mil will help clean that up a little bit. Now, the one thing we're going to need to do is we're going to take and rotate that whole thing around to see exactly how much, and I might actually have I might have to modify that center design, and let's just do that now. So I'm going to do this. I'm going to grab those 2 pieces. I'm going to grab all 3 like that. I'm going to hit create a copy, and I'm going to move them over 50 millimeters like that. And I'm just going to join them together like that. And I do let's see. I'm just creating I'm going to create a part that I can use to help me figure out all my clearances in kind of an easy way. So we're gonna do that. Now I couldn't tell, was that, I think it was on center before. That's okay. Okay, so there we go. So I did that. Now, the reason I'm going to do a revolve, and I'm going to, why is it? Revolve axis is going to be that. There we go. So the angle we're only going to do, we're going to do 180 degrees. Actually, we're only going to do 90 that direction. Or I could do, fine. Cancel. All right, we're going to try this one more time. Select that. Oh, this is annoying. Very annoying. I can do it a different way though. I can take and select that plane. We're gonna do a big cut. Cut all the way through it, and that will allow me to do this. $90 degrees that direction. Okay. This will make a little bit more sense in a moment, hopefully. Now, the reason I'm doing this is just so that I can bodies. This should tell me exactly where everything is going to rotate. So I can see if the handle is going to collide. So I can see here, like as that thing would move around, it's couldn't do a hinge point. Yeah, I could add the, add the constraints and all that. This is just, the only thing with like doing all that is moving it, and then everything, you never get everything moved back. It's kind of a pain. I just don't like designing a ton with the constraint stuff on. It bugs me a little bit. So what if I go to, that's, I'm guessing I'm gonna have to be closer to 20, but let's check. Actually, it's not bad. I think that actually, I'm not going to do that. I'm going to turn off body 1 and 2. Yeah. So I'm going to add a couple of extra cuts that add, they won't look totally normal, but they won't look, I think it'll be fine once you see kind of the direction that I'm going. And do that. 75. Actually, I'm gonna move that. I'm just playing around trying to make this kind of look the way that I want. Okay. Let's see what this is going to look like. So some cuts like that on the corner, and I think that will actually help me. I've got some clearance down here. That will be a bit of an issue, but almost there. Okay. Projecting those two surfaces, and then I'm just going to go a millimeter in there. That. All right, sorry about that. Getting close. Just with how, I don't know if any of you guys have ever used one of these things, but they are very nimble. So you want to make sure that they rotate all around. So since we did that, now I can go through and kind of add some more. I can add some fillets, and a lot of this stuff may not look as odd as it was a minute ago. That. That one actually might be all right. We should save though, because we haven't done that yet. Oh, I spelled it wrong. That's okay. And that. Perfect. See, while all of that may have been kind of convoluted to get done, once you just throw a bunch of fillets at it, it kind of looks like you designed something funky. And we're going to do some very small filleting on the handle, which will also help with clearances. Looking okay. I think. Heavy vignette. Heavy fillet, heavy vignette. Always my go-tos. And we're gonna 5 there. This top, I think, I don't want to fillet that whole thing because I want this to kind of flow into that part of it. But so we may have to do it the old-fashioned way with it. Project, and then now let's fillet those lines. 7, sure. Do that. 22 millimeters. Yeah. Make it match into there. See, it looks pretty good. Now, one thing you, I'm sure, have noticed at this point is that I've only done all of these things to basically one side of this. Now, you can use the mirror features a lot to try and get everything, but I'm going to cheat way harder than that. And basically what we're going to do is once we get a lot of this stuff done, I'm going to cut almost this whole thing in half and then mirror it. And then it'll just have everything I did on one side of the body on the other. Huge cheat. Not necessarily the way that, it gets stuff done. I don't care how you do it. Five there. I'm going to fillet this whole thing, and then we're going to go back and cut out the clearance we need in this area separately. I think we can do, oops. Let's, I think I need 17, technically. Oh. We're just going to take that, cut that up, and then we just need to make sure that we're only cutting object 2. Okay. Thanks, Brian. Are you sure you're not fillet king of for Dyson? What? So, see, that's the cut we just made there to make sure everything clears well. All right. Side here, you know, they've got that echo. I suppose that's where we could put the HD stuff, right? Would be an option. Trying to look at some other features of this one. It does appear that it's got a, it's actually like a bit of a slope to the front, which we could, I'm not going to do that now. No. I considered it. I'm unconsidering. It's been unconsidered. Oh. That there. So we need to add some handles. We need to add some buttons, all of that. We also still need a pallet, of course. One thing that's bothering me is the look of the front of this. So I'm going to just do a bit of a gentle arc cut. Just to give it something. Just too blunt. And okay. Okay. let's do some of that mirroring that I was talking about just to get the overall style. So I'm going to cut not everything. I've got everything selected here. We do want the base. I'm going to cut the base. Body 2 is the top, and we are going to do that. Body 3 is the wheel. I don't need that. 6 is the inner shaft. I don't need that. 8 is the other bearing. 9 is the top portion. I don't need to do that. 11 was the handle. 12 is that, and I do need it. So cut the whole thing in half. So mirror, I'm going to select bodies and select those 3 bodies that we just did. Mirror plane. I don't know why I didn't mirror that one body. So we're going to do it again separately. Okay. So now we got all those cuts we made on that one, but and the top, the feet are in there, the whole deal. Done and doneer. So we could do a, I don't want to do a small chamfer like that. I guess we're going to avoid that for now. We need to add the handle. We need to draw a pallet, and that's I need to make the attachment for this so that that actually looks like something. Or so I think we should maybe it's gonna print probably face down. I guess you could print it standing up as well. Trying to think if we want to screw it in from the front side. What do you guys think of that? All the way, make some counter bores, 2 and 3 screws from the front into it. They could be recessed enough that I don't think they wouldn't necessarily be apparent. I think that is reasonable. Hide that for a second so that I can project that. And line. We'll do a two circles. We'll make sure that they are 6 millimeters is all. So, and now we'll space them 20 millimeters there, and we'll call 6 mil off the bottom. The depth, oops, that was too far. Can't go that full distance because then it won't have anything to attach from. So that was negative 25. So we're going to do negative 20. Leaves us enough. Now we need to do the 3.5 millimeter hole there. That would be so an M3 screw can pass through. 3.5 Q. Select those 2 things. Select the vertex. And again, now we need some 2.6 millimeter. Gonna hit project on those 2 surfaces so it gives me the center of the circles. 2.6, 2.6, Q, 8 mil deep. So now that will attach from the front side. Should we add some sort of something on the front of this to make it look not just big and flat? Thanks again, Brian. I appreciate it. Brian said I put a 3300 kV Holmes motor on my Pro and it doesn't have any good drag brake running the Mamba X ESC. I'm running a 3300 V2 Polar Pro. That's weird. Man, the Holmes motors usually have a ton of drag. I'm trying to think what one very simple thing is, have you programmed your throttle, your neutral position just by programming throttle position? Like if it doesn't see that perfect neutral, or adjust your deadband, neutral with deadband, because otherwise it should really have a lot. You can adjust the drag brake ramping as well. Maybe bring it on a little faster. That flash section would be a great place for a sticker. That's an option. So, let's do like even if we just do something, let's inset that area like -4. That, and we'll just do -1. That'll drop it in a little bit. Let's go around, fillet that inset pattern. Five millimeters, and then we'll do a that's just a little bit of something. At least it breaks it up slightly. We could also let's just do something super simple. Thanks. We could do slot, center to center slot, and do that. Let's put a dimension on that of, say, 1.5. I'll go 2. And then we'll go -2 on that. We select those lines, go 3, fill it again, go 2, fill it one more time, we'll go around the outside edge, we go 1. It's not anything purposeful, it'll break it up, and once it's 3D printed, it'll be, I think it was too heavy though. Let's narrow those up a little. Let's go back to 1.5. 1.5. And the cut, we're going to go to -1. We have to adjust those. So 1 on the first one, and undo that. Select. Hey, Brian. Would you recommend the Rock 412 HD? I'm getting really upset because the drag brake on the 3300. Man, I mean, I would love my Rock 412s, but that 3300 Polar Pro, that's a good motor. Like that's a really, and the Mamba X, like that whole package deal you picked like just a known, typically high performance, no issue deal, which I'm sure is what you were expecting, probably what you had heard previously. So that's why I'm like kind of wondered. It's like, I feel like you just need to kind of try a calibration on it. Like I said, program your throttle position. That's the plug it in with the throttle held all the way. Hold the throttle all the way, plug the battery in, set the full throttle position, set your reverse position, and then set neutral. See if that helps first, and then from there, make sure that confirm the settings, plug it into the mom. Hopefully you have using a Castle link. Obviously, Castle links are super powerful and will help you program things a lot easier. Hopefully, that's what you're able to use, because that's a. I think that there's something else up. It's definitely not that motor has low drag brake, and I would hate for someone to spend more money when they already have something that's actually super solid. Um, and definitely, I think that the issue is somewhere else. It's it's 100% crawler reverse drag brake. Yeah, that sounds right. Um, so there's got to be something else happening. I'm trying to think of what it could be. It's one of those things that it's really um, hard to think of without, like, either being in front of it or. But I don't think that it's an issue of your motor or your, you know like what you made as a choice, because I think that is, you made a solid choice, and I think that's something else is happening. I'm trying to figure out trying to cut the right piece. There we go. I think that's the right piece. Okay. So that is very frustrating though. I can try can't imagine what is actually going on there. Oh, I need to join those two first. Yeah, let's go 10 like that. Um, did you say that's 100%? Yeah. I think. Hmm. I used the cast link already, but it didn't work. Like, it didn't affect anything, or it didn't allow you to get it hooked up. Sorry, I will not eat ice on a stream. That's bad. Okay. So I beefed up the connection point here for that. Now that will affect my clearances slightly, but you'll still be able to get pretty close to the whole thing. If you're using the white auxiliary cable, try unplugging it, Dana says. And that's actually a really good point. If you have that white auxiliary cable, I don't have a problem with the Revolver V2 1800. Is that on the same ESC with the same settings? Or is that on just a different truck that you're running a similar motor? Because that's my concern, is that there's just something in the settings or radio. Like Dana said, if you've got that auxiliary cable plugged in, it could be overriding whatever you programmed if you've got it programmed to control drag brake. Um, so there we go. We've got this able to be attached. You'll put everything in from the bottom there. The only thing I didn't do is I haven't put anything to actually, if you pick this thing up, technically that lower section could slide off. So yes, same truck, same ESC. Okay, that's even more intriguing. You have me puzzled. Let's see. Oh, that's I don't know. I guess I've never heard of a motor like having just bad drag brake settings, like not like functioning otherwise, but not working in drag brake. that, and I'm going to make sure that that's body 12. So select those. Had a little bit of an interference right in that area. No. A little too much. Okay. Okay. Motor wires ABC according to the ESC. That's almost one that I would have. Like if I was running into that, like with those same situations, I guess without having that type of ESC in front of me and checking all that, I would almost have to message Holmes through the website, because that's quite a conundrum. Right. I need to stop trying to eat ice. It's a bad habit of mine. Hello, Schultz. Schultz has been one to be around a forklift or two. Speaking of, let's throw some text down here. I'm not going to do it vertically like theirs was. Let's do 15. There we go. Negative 0.4. Branded in the side. I'm just disappointed Josh isn't making a powered one. Yeah. That, these streams would be even longer than they unnecessarily are already. One thing I didn't check is to make sure that these things could still move or rotate. If not, I might have to make that section bigger as well. So we'll check that as we get closer to the end. Although this part of it is pretty close. Pretty close. Let's throw some very small fillets in these corners. Just enough to clean it up a little bit. I think we'll throw a chamfer on those as well. That. Okay. What else do we need? I don't really know that we need anything other than the actual handle part of it. How is the brown part and green going to stay together? Frogfather, good question. That is something we need to add. I'm thinking 4 screws at this point. Let's turn this off. Project. We're going to project the bottom of that so I can see where everything is. And let's do 3.5. I'm just going to draw it on one side and I'll mirror it to the other. $35. I think these should be simple. X. Now we'll just mirror those two holes to the other side. Okay, and we'll cut all the way through. Being that these are on the bottom, I should probably let's put a 6mm counter bore over top of them just so you can flush the button heads into it without them showing on the bottom. You wouldn't want your forklift hanging up on those all the time. Or your pallet jack, or whatever you want to call these things. Fork, truck, pallet, forks. We'll go -2. Give you enough. Next week, you should print a toilet. You know how many times that's been suggested? And I don't get why. Why does everybody want a toilet? So I definitely think we're going to have to modify this bottom section to make sure that this, that will rotate, but that'll be right. Now, grab those, 2.6. And we'll just make these go 10mm up. So now we can attach the bottom, that part to the base. That will sit properly on the bearing, so that will hold it in place. We need to do some cleanup on this thing still. I need to make sure that this is clear. May have to go to slightly narrower wheels. Not a big deal. Actually, that's probably a better idea anyway. I went really wide on those in the first place. Let's draw the handle portion of this so that it starts to look correct. Let's use the spline. I don't use that very often. I know why I don't use it very often, because I don't like it. It's not very engineery. And that's fine. Go. Sure. These heights don't really matter all that much. It's 10, and now I'm going to offset it inwards by -3. Trim those both to construction, and then we're just going to mirror all of that to the other side and clean it all up with a bunch of fillets. Those wheels will not rotate very far. I agree. That's why I need to make sure and get that cleaned up. And we still need to do a pallet, but a pallet will be, I mean, I could do a pallet speed run style. Not going to, but I could. 3 there. So we'll do 6 to the outside. That. Normally they have the buttons and levers and blah, 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 blah. We'll get that. I just want to make sure everything else is going to function because I still have to do the other side of this, which really means I need to cut this whole thing in half. It's fine. So that'll work. Most likely you're just going to have to tension it a little bit so that it Josh will still have to connect the front wheel point to the base. Front wheel point, what do you mean? The palletiest of pallet jacks. And yeah, these wheels will not rotate very far. Also, yeah, you know, it's just like pallet jacks in our warehouse. They'll still get stuck on a freaking zip tie, and even the full size ones get stuck on little stuff. So deal with it. I think I made these like 10 mil wide, and I think I'm going to drop it all the way down to 5. Yeah, I did make it 10 mil. So I'm going to drop this whole thing down -5. Yeah, so that'll give me a couple of things to do. Because I'm going to do we're going to do a 3.5 millimeter face. And that whole thing is going to go in 1 millimeter. So you put an M3 screw in, and now the only thing I need to do is so that's body 3. And body 4 I could technically delete. Delete. Did that blow up a bunch of other stuff? I'm gonna double check. No. Okay. So this here is my, so I need to make a recess for the outer bearing. So that's going to be a 10 mil bearing. So I need that to be what? Actually 7 -0.25. So then the outer race won't rub at least, and it won't have an issue. I'm going to add another millimeter of material there just because. We're going to put some small chamfers on that wheel. That's too heavy. Edit. I'll go 1/2 mil. Make them roll a little easier. Bearing will go in. So the only other thing we need to do here is this is going to have a 3 millimeter inside, so 5. That. And do I don't remember what that surface was. How big did we make that wheel? Yeah, there we go. -0.5. A little bit of clearance there just so that things don't rub. All of those things are things that need to get mirrored. So more cutting in half and mirroring the bodies. Okay, looking good. So let's see. Does that work out now? I'll have, I guess we can check a couple of things. We can select bodies. I'm going to select that one and that one. And then we're going to set our pivot based on the center point of that. We're going to select OK. And now I can rotate this. So it goes 90 degrees that way. It goes 90 degrees that way. Yeah, we got it pretty close. After I narrowed the wheel in half, but, and then, I mean, with the other wheel on it, it'll be the exact same. It'll just be the other direction. So, nailed it. Nailed it. That's impressive. I don't care who you are. Throw that. You're gonna have to use short screws and butt up to themselves in the middle, but that's not a big deal. Shouldn't be a big deal anyway. I do need to make a printed. I'll probably just do two wheels, one that uses a bearing, one that doesn't. Obviously, bearings are a little overkill, but that's fine. Throw one of those on as well. And I need to, let's isolate this thing and just do a little bit of clean up here and there to make this look a little better. I only did 3 sides because I plan to cut it in half. Go. Chamfer around that, 1/2 mil, about 1 mil, 1 millimeter. Yeah. Okay. Cut it in half to make all of our add all of our changes, and there we go. We got everything on both sides, and it looks about like I wanted. Now the only thing, like I said before, I didn't add the I don't have a screw or anything on top to 12 to make sure that everything doesn't come off, but guess we could or should do something like that so that when you lift it off, it doesn't all fall apart. So if the top of a screw is 5.6 millimeters, that's just going to be our, and we need at least, so we got a 3 millimeter regular diameter. I just need it to overhang a little bit. That's a tough one. Actually, no, I'm not going to do that. If you're worried about it, you can add a little glue. I think that part of this is pretty much done. I need to clean up the handle, but we'll do that. I'll do that before I upload it. Let's quickly do a pallet. Pallet dimensions. This should be super quick. Okay, so let's just I don't know why I selected that face. Do it on that plane. And the length of these is going to be 4.8 inches. The width will be 4 inches. We're just going to go one, oops. (122 by 102), so that the dimensions don't bug me as much. So in that way, now can I find 1, 2, 3, 4, 5, 6, 7 pieces of slatting on top? Top deck is 1 by 4. So 1 by 4s are actually what? 3/4 by 3.5. So if I was just gonna see what that would be, 0.35 inches is 9 mil. Okay. 9 millimeters, and I'm just going to linear rectangular pattern. Come on, let me just. There we go. Okay. So I need, what I say, 9 or 7? 1, 2, 3, 4, 5, 6, 7. I need 7 of them. And I can basically just stretch them how I want. That. Now, like that. And what normally be 1 inch, so 0.1 inches, so we'll call it 3 millimeters. 3 millimeters up. These are going to be new body. Okay. Top. Going to select them all. And we're going to move them upward. I just want to make sure that they're going to actually work on what we designed. So even if it's not 100% accurate, I'm going to make sure that it fits our pallet jack. Save, save, save. Save it as 14. This 14th scale as well. Oh, I could, but since we made it up for all kinds of hardware, it's like that's. I mean, it's not impossible by any means, of course, but it's much less easy. Modella time. I would like a beer. Like, you know what? Nicole and I are still on our fancy stupid diet, and I eat like a 9-year-old normally, so I'm craving junk food so. So this would normally be 3.5 inches again. So what would 0.35 be? That'll work. We're gonna 9.5. We're gonna make that a little bit more. Yeah, that'll be fine. So actually, I'm going to just go to, we're not going to enclose it on the bottom, I don't think, because I'm not going to, I want to go on the pallet jack and still be able to move around a little bit. And if it was the normal height, normally you would put it on a pallet jack and you'd raise the pallet jack up. This won't have that, um, so I'm not going to totally do that. But let's add the fork holes in the side. Fork hole. I guess we should make these for our fork hole widths, though, right? Which, what was that? 69 millimeters wide. So let's make sure that that's 69 plus, well, we'll say 5, so 74. Make sure that it's spaced properly. Using midpoint lines mainly. Okay, so that, and then what was the width of ours? 16. So make sure that these are, well, I mean, we'll just do, I added 5, so I need to add at least 5 to each of these. So that's 21. That would, that enough? And needs a little bit more. That. Yeah, that'll be right. And so we're gonna do -5. I'm gonna do this as a new body though, because I'm going to take and copy that, oops, to the center and both sides. Oh, we're gonna hit that, create a copy. Now, that is that the center? That is not the center. I probably should just do some math, but close enough. Definitely not the way I would normally do it. I would normally try and do the actual math, but whatever. Okay. Hey, Brian, when are VFD? I don't have a date on that for you right now, actually. Ooh, that's weird. Why did that not? I mean, they're in production, but I don't have a date for that. Did I not center these things when I drew them at first? I don't think that I did. There we go. That was 102 millimeters wide, so 50. There we go. Okay. But yeah, I don't have an exact date on that for you right now, because I mean, right now, honestly, it's kind of just trying to keep up. Stuff's crazy busy right now, and it's just, we're all kind of running around with our heads cut off. Pallet, close enough for government work, exactly. Pallet and pallet jack. Really should have. I'm going to duplicate. Oops. I'm going to duplicate that color, edit it, and make that thing like red. Done. I'm going to make that red and the palette that color because that looks better. So, and print with the boards down. Yeah, absolutely. That way you don't get nearly as much support, or you should definitely print it without support. It'll bridge those little gaps without any issue. And print it with the wood PLA if you have any. There you go, right? Because that stuff is kind of cool. Add some little fillets just to class it up. And you'll be in good shape. Like that. Right? I'll get everything else cleaned up, but this thing's done. We're going to call this thing a completed project. Bob's your uncle. I'll do a few little cleanup things here as I separate everything. I'll finish up this handle to make sure that everything, I need to cut it, mirror it, make sure that the screw holes are the right size. Let's save again. But there you go. I'm actually even gonna print this. I'm gonna use orange up top, black for the forks, black for this piece, probably black for the handle. And then I feel like I should get some of the wood PLA for that. And I want to print the old skee ball machine in the wood PLA because I always thought that one was kind of fun. So that's going to do it. It is 8 o'clock, just almost on the dot. We did 2 hours. Pretty good time. If you guys are still watching, hit the like button if you enjoy it. Appreciate everyone's support tonight. Let me go through and thank everybody. Bald and Beautiful, Jeremiah, Brian Sherwood, Brian Ratcliffe, bunch of Brian Ratcliffe. Appreciate it very much. Yeah, did I miss? Yes, got them all. Appreciate it a bunch. If you guys have any other questions, might have to get into 3D printing. 3D printing's fun for a ton of reasons. It's another thing that allows you to do. I mean, maybe not for printing pallet jacks, but why not? Pallet jacks can be fun. It's something else that you could possibly enjoy. You could enjoy building a scale shop. And there's nothing wrong with that. A lot of guys have some really cool scale shops. I'm thinking something like this. It'll look kind of fun. I bought orange or yellow PLA for this project specifically because I liked kind of how that color was. And turns out that I bought 3mm filament instead of 1.5mm filament. I've never done that before. So a cool project would be a rotary lift. Four-post lift, except I think 3D printed lifts for a vehicle is just, it wouldn't be strong enough especially if it looked good. I've seen the 3D printed ones and I'm just like, I don't like them. So that's why I've never really got into that. Could be a static lift. Yeah, I know what you mean. But I had ridiculous bearings and stuff to things. So I like them to be at least somewhat functional. So, anyway, if you guys have any questions, let me know. I'm going to kill this thing off. Lifting ramp for 1/14 trucks. I don't do much 1/14 stuff. I know I have the one truck, but for me, I like the 1/10 scale size stuff the most. I think that it seems like there is a lot of 1/14 scale accessories anyway. Bearing count 6. So we had 1, 2 on this, 3, 4, 5, 6 bearings. Yes, 6 bearing pallet jack. Yeah, and everything else looks about like I expected it to in the end. Just trying to figure out how exactly I want this to look for the Thingiverse thumbnail. Thinking something like that. That looks about right. Uh, is that a bearing record? Oh, I don't know. The the washing machine I think had 6 bearings even because it had like 4 on the top. I think it had 6 as well. Can't remember if anything else had more than that, but that was either way pretty good. So anyway, all right guys, appreciate it. Again, thanks, and we'll see you on the next one.